Hello, we're going over 3.2, which is the elimination method, also known as the addition method, and it's an algebraic method for solving a system of equations. And so instead of a graphing method, so we won't have to graph these things unless we decide that we want to. And so let's go check them out and see how we do. And so I've got the basic how-tos of the method, and there's choices, but this is the basic strategy to get you started, and then after that you can kind of create your own strategy as you go. The first step is to put both equations in standard form, and that way that both equations are looking like each other. And so the x's are lined up with the x's and the y's with the y's and the number with the number. And you don't want any decimals or any fractions because that makes it difficult to solve. And so if we encounter some of those, I'll show you how to get rid of them. And then the second step is to choose a variable to eliminate. And then you're going to make the coefficients opposite. And I was going to play you a song about that because there's an artist that sang a song about step 2 here. And so because you get to choose. See if you can hear it. We can pack up tomorrow. Tonight, let's flip a coin. Heads Carolina, tails California, somewhere greener. So I'm sure what she was really meaning when she said, let's flip a coin, is about this right here. Because you can do either one, your choice. So, and I know that she was really singing, heads eliminate X, tails eliminate Y. I'm sure that's what that she was saying. So, or you can figure out which one would be best to eliminate. One of them might be a little bit easier looking than the other. And then the key is to have their coefficients opposite, no matter what you choose. Then what you do after you've got the coefficients opposite and you've got them lined up. So I guess you got them lined up and you've chosen a variable to eliminate and the coefficients are opposite. Then you add the equations together. And what happens when you add those equations together is you're going to get there are three possibilities. Either it creates one equation, one unknown, which you know how to solve. Learn to solve those in chapter 1, practice solving those in chapter 2, and here we are, now becoming experts at solving those in chapter 3. So then you can solve it. Once you do that, you'll know one of the variables. So if you eliminated x, then you'll have an equation that has y in it, and you'll solve for y, and then you'll know what y is. Y is 57, or y is 32, or y is -½ whatever it is, you'll know it. And then you can use substitution to find the other variable. Now that you know x, you can use, or you know y, you can use what you know to find the other variable. So if you know y, you can use it to find x, or if you know x, you can use it to find y, either one. And then the end of this situation is you write your solution as an ordered pair. And this is the part that people skip, and it really hurts them, is that you check your answer by substituting it into both original equations, and it needs to make both original equations true. If you only made one mistake, then it will solve one of the equations likely and not the other. And so people tell me, well, shouldn't I just be able to check in one of them? If it checks in one of them, it's right. Well, if you made one mistake, it'll likely work in one of them and not the other. And so no, it's not good enough. If you're wanting to check it, you need to check in both equations. If another possibility, so this happens or this happens, that you were trying to eliminate x, pretend like, right, because it's choice, and you add the equations together, and unbeknownst to you, x's eliminate, that's what you wanted, but the y's eliminate too. So that can happen, right? You didn't plan on that happening, you didn't try to make it happen, it just happened. But what you're left with is what it makes the difference. If you're left with a true statement, like 0 equals 0, or 7 equals 7, then there are infinitely many solutions, and you can write IMS. And then I'm going to also show you the fancy way, remember, that the book showed us. And so there's also a fancy way of writing infinitely many solutions. And we've got to learn that fancy way because we're heading to intermediate algebra, right? And so, but don't worry, it won't be tricky. We'll be able to do it easily. And so there's a fancy way of writing that there are infinitely many solutions. And then I have some ideas of how you can check. Check your work. And that is, you could solve both equations for y, and if you end up with the same equation, then you know that it's IMS. That's what happens when it's infinitely many solutions, is that when you graph them both, they're right on top of one another. So essentially, it's your two equations are not unique from one another. They're the same equation. Then the other possibility, and it can't happen that this and this and this at the same time. It's or. This happens, or this happens, or that happens. And it can't be all three of them at the same time. So there's either one solution, or there's infinitely many solutions, or there's no solutions. And what happens when there's no solutions is that when you make your coefficients opposite and you add your equations together, that both variables drop out, just like it happened here. But instead of having a true statement like 0 equals 0, you get something false like 5 equals 7, or 0 equals 10, or something like that. And then that tells us no solution. And you can check by solving your equations both for y. The two equations should have the same slope, but not be the same equation. That means they would have a different y-intercept. And so I'm going to just draw a picture of how that could happen, remember? So that's the, right? They're parallel with one another, and they don't cross one another. And so when they're parallel with one another, they have the same slope. But since they have a different y-intercept, they're not the same line. There's no solution. Remember, the solution happens where they cross. Whereas this, when you have something like this, they crossed one another, and where they cross one another is your solution, and that is your x comma y. So if you wanted to graph all of these as well, you could, along with. Okay, so we're going to give a try. So this is problem 6 from your textbook in section 3.2. And I notice that the first step, remember, was to get the equations lined up in standard form. And I noticed this is in standard form with the x's and the y's lined up with one another and the numbers lined up. See how the equals is lined up as well. Standard form means x and y are on the same side of the equation, which they are. X and y are on the same side of the equation, and the number is on the other. So your book calls that standard form. There's no fractions, so we're all over step 1. Done, right? No decimals, no fractions. Notice how I have my x's, my y's, my number on the other side. Both equations need to look like that. It's all done. Now I want to choose a variable to eliminate. That's where I get to flip the coin, right? Heads or tails. But look here. Without me working very hard, do you notice that the y's are opposite of one another? Negative 1y and positive 1y. So actually, without me doing any work, the y's would eliminate each other. And so I am going to choose y to eliminate. So this is my thought. Eliminate y. I can't get that song out of my head. I'm sorry that I had to play it. I was listening to it earlier. And so, and I thought, that's what we're going to be doing today, is we're going to be flipping a coin. So we decided we would eliminate y, and then the coefficients are opposite, so I'm going to just do my adding my equation together. Remember, there's a 1 here. So this is 1x plus 2x is 3x. Negative 1y plus 1y is 0. They eliminated. 4 plus 8 is 12. And then I told you guys that we would have one of three possibilities, right? We would have, my cat's coming back. She was torturing me, tormenting me earlier. We would have one equation with one unknown that we could solve. So 3x equals 12 is that situation. Notice I do have a variable on one side and the number on the other. This talks about having numbers on both sides. And this one talks about having numbers on both sides of the equation. But I don't have that. I have exactly ready to solve it, right? So I'm going to divide by 3 because I will solve for x. So now I know that x is 4. And I want to know what x is and what y is, because my solution, remember, is an ordered pair, x comma y. And right now, I have that x is 4, and I want to find what y is. And you can use either equation. You'll get the same answer no matter which one you use. So if you choose to use equation 1, x equation 1, right? X minus y equals 4. So you're going to be putting in y is 4, x is 4, x is 4, sorry, y equals 4. So I would take away 4. I'm going to solve this now. One equation, one unknown, right? So I get negative y equals 0, and divide by negative 1, right? There's a 1 there. Divide by negative 1, and 0 divided by negative 1 is 0. It really bothers people when the answer is 0. 0 is one of my favorite numbers. There's nothing wrong with it. So that's our value of y. I want to show you that you would get the same exact value if you had used equation 2. And so 2x plus y equals 8. This is equation 2. And remember what we said that x was. It's 4. 2 times 4 plus y equals 8. So I got 8 plus y equals 8. And I'm going to take away 8 from both sides. And I get y is 0. So it oughtn't matter which one that I use. And then you do want to check your answer just to make sure. So let me show you how to check. I didn't need to do that, right? Because I already found it here. Or I could have done it in the second equation and then I wouldn't have needed to do it in the first. So I kind of burned some of my room for checking. But that's the most important step that people skip. And when I say that you ought to check, people always say to me, will you mark me wrong if I don't? And likely, yeah, I will, because you likely will have it wrong every now and then if you don't check. So when you check, you plug in both x and y at the same time and make sure that it's true. So 4 take away 0 equals 4. Yeah, that's true. It has to work in both equations. And if you've only made one mistake, it'll likely work in one equation and not the other. So 2 times x plus y equals 8. We're going to be plugging in x is 4. So 2 times 4 plus y, which is 0, equals 8. And that's certainly true as well, right? 2 times 4 is 8 plus 0. So hot diggity dog, it worked. So this is our answer. And we did a lovely job on it. So we're going to try number 30 here and see how we do. And number 30, step 1 is it's set up. They're both in standard form. So this is in standard form, no fractions. This is in standard form, no fractions. And so we're ready to choose a variable to eliminate. And this is where you get to flip the coin, right? Should I eliminate x or should I eliminate y? And no matter what you say, I agree with you. That would be a great thing to do, would be to eliminate whichever one you said. Doesn't matter. You'll get the same answer. In the end, you'll get the same answer. So I'm going to eliminate y just because, right? No reason not to eliminate y. So the goal when you eliminate y is that you have to make the coefficients opposite of one another. And the coefficients are 2 and 8. They're not opposite of one another. If I add them together, I'll get 10y. I will not get 0, which eliminating them means making them opposite so that you can get 0. So what you have to do is you have to find something called the least common multiple. the LCM, the least common multiple. And that's the same guy, but it's not looked, we don't have any denominators here, but that's the same guy that the common denominator was when you had fractions like 1/2 and 1/8, and you were going to add them together and you wanted to make their denominators be the same. You called that the least common denominator. And you could find that least common denominator by a method called multiples. And that's why it's also the least common multiple. So if you're thinking, well, the least common denominator is 8, well, you're going to find that the least common multiple is 8. And you can find it by count bys, right? 2, I'm going to count by 2, 4, 6, 8, and then this other one's 8, right? And so we started our list here, and I want to go until they have the same number in the list. I had to go a ways in the 2 list, but I didn't have to go very far in the 8 list. So 8 is the least common multiple. And what I want to do with that least common multiple is I want to use it to make them be opposite. So since this is positive 8, I want one of them to be positive 8y, and I want the other one to be negative 8y. And this is already positive 8y, so this one's all done, right? No need to work at all. It's done. And so I'm going to just write that here. 7x plus 8y equals 7. But this equation here, I want to turn it into negative 8y. So I would have to multiply 2 by negative 4 to do that. So I'm going to multiply by negative 4. Now, it's not okay just to multiply the 2 by negative 4. You have to actually do the whole side by negative 4, which would mean you would have to distribute that. And what you do to one side, you have to do to the other. So you'd have to do it to that 11 over there as well. And so you have to basically do it to all 3 pieces. So times negative 4, that's negative 20x. Times negative 4, that's negative 8y. Times negative 4, that's negative 44. And now when I add them together, right, this has got kind of small. Now when I add them together, you notice the y's will eliminate, right? Because negative 8y plus 8y is 0. And then that will give me one equation with one unknown. So I get negative 13x, right? Negative 20 plus 7 is negative 13 equals, and then negative 44 plus 7, and you're free to use a calculator if you want. You can get your fingers out if you want. I got negative 37 when I did that. And I'm going to divide by negative 13. So I get x equals 37 over 13, and negative divided by a negative is a positive, and it doesn't look like it reduces or anything, and your answer doesn't have to be a whole number. Your answer can be a fraction. So there my answer is being a fraction. And then I want to find out what y is, right? I eliminated y, so then I found out what x is, and now I want to know what y is so that I can write it as an ordered pair here. And so that's going to be our next part of our plan, right? And there's multiple ways of doing it, and I can't help but show you more than one way. Whenever this is a terrible fraction like this, then substituting in will give me my answer, but I'm like, I look at it and I think, ooh, I don't know that I want to solve that, right? So substitution was good, but let me show you. Let me get another piece of paper, a scratch piece of paper, so that I don't muck up my work. I went for some scratch here, just because I want to show you what it would look like. So if you used equation 1, which was 5x plus 2y equals 11, and you put in what we said about x, 5 times 37 over 13 plus 2 times y equals 11, that's pretty hard to solve. if you want to know the truth. And any time that something's hard to solve, you have a good shot of making a mistake, right? And so I could solve it, right? I mean, I would be fine to solve it. My first step would be to multiply 5 times 37 over 13. 5 times 37 over 13. And when you do that, you get 185 over 13. Plus 2y equals 11. And then you would take away, well, you could clear the fraction by multiplying by 13 if you wanted. Let me do that, because this fraction's giving me nightmares. So when I distribute here, this is 13 times 185 over 13 is 185. And when I distribute here, that's 26y. And when you go here, you get 13 times 11. 13 times 11 is 132, right? I think that's one I know. Is it 13 times 11? Oh, 143. I'm glad that I didn't brag too much about knowing it. Thir 11 times 12 is 132 maybe. And then I'm going to take away 185 from both sides. And so I'm hoping that you're thinking, wow, that's really, I'm having to really pay attention, and I'm really having to work hard here to get this. So I get negative 42, and I'm going to divide by 26. And so I get y equals negative 42 over 26, and I get negative 21 over 13. Okay, that's one way of solving for y. You can also plug it in the other equation here and solve for y, plug in the x value right there, and you'll get the same value. Won't get something different. But that's also a lot of fraction and a lot of chance to make an error when you have fractions running around and everything. So I want to show you a way that's actually a little bit easier when you have a hideous fraction like this. And that's not really a hideous fraction. That's actually a pretty nice fraction. And that's just to sort of start again. And instead of eliminating y, eliminate x. So now think about your least common multiple between 5 and 7. Well, 5 and 7, they don't have anything in common if I was to start counting them out on count bys, right, for the least common multiple. 5, 10, 15, 20, right? I'm going to get to 35, and in this list, 14, 21, 28, right? I'm going to get to 35. And so I really can't do any better than just multiplying them together. 5 times 7 is 35, because they didn't have anything in common like 2 and 8 did. And so anyway, so what I'm going to do is I'm going to take the top equation here. I'm going to erase here. And I'm going to multiply it because I want one of them to be positive 35x is my goal. So if I multiply this by 7, multiply by 7 now, 7, every piece, then I'm going to get 35x. So I'm going to take this and times it by 7. That'll be 35x. That's equation 1, right? Remodeled times 7. That's 14y. So I'm taking and I want to make this positive 35x. And I had to multiply this by 7. So I'm multiplying by 7, by 7, by 7. Because what you do to one side, you got to do to the other. If you have two things on the side and you're multiplying, you have to distribute, right? And times 7 is 77. Most common boo-boo people make is not to do it every single term. Now I want the other one to be negative 35x. And so I want to multiply the 7 by some number so that I get negative 35. And you're right, I got to multiply by a negative, so I'm going to be multiplying now by negative 5. So by negative 5, by negative 5, by -5. I'm going to multiply them all by -5. So that's going to be equation 2 remodeled. So this is going to be -35x when I multiply here. Then 8 times 5 is -40y, and you can use your calculator. 7 times 5 is -35. Do you see how I left off my negative on accident there? You have to really be careful, because people tell me, you know, that, hey, these are not really hard. It's just if you make one arithmetic mistake or one transferring mistake. And so now I have them set up so the x's will eliminate. So when I add the equations together, I'm going to find out what y is. So, and you notice I haven't had to deal with any awful fractions at all right here. Even though there was awful fractions, I see them. I didn't have to deal with any. All I had to do was deal with multiplying by 7, right? And so, and then multiplying by -5. So far, not, I mean, work, but not treacherous, right? So 14 take away 40 is -26, y, equals, and 77 take away 35 is 42. And when you divide by -26 to solve for y, you get y equals 42 divided by 26 is 21, and it's negative. Positive divided by a negative, 21 over 13. And so, and you notice that when we did it the other way and we dealt with all the fractions, we got exactly the same answer. And so it's whichever way you like to do. So this was, we used the elimination method to find x, and then we used a substitution to find y. Whereas on this other method, we used elimination to find x, and then we used elimination to find y. And so it doesn't matter. And you notice I didn't have to deal with any fractions until the very end, just reducing a fraction, where here I had to multiply fractions together, and if I would have lived with the fractions would have been coming out my ears, but I decided to clear them. And so your choice on that. Okay, so my answer needs to be written as an ordered pair. And so that is 37 over 13 for x, and -21 over 13 for y. And you should always, so this is my answer, and then you should always check to make sure that it worked. So 5, this is equation 1. Equation 1, 5 times the what plus 2 times the what. I missed my opportunity, equals 11. So I'm going to be putting in 37 over 13 for x and -21 over 13 for y. And I'm going to put my calculator to work and have it do that. And I don't like this calculator as well as I like the other calculator, but I think I left the other calculator in the other room. I didn't, and so I'm happy. I like this calculator better than that one. And so I'm going to get it out. Okay, so 5, you can like whatever calculator you like, right? And you're not allowed to use a graphing calculator, though. And so if you don't have any calculator other than a graphing calculator, then you'll need to do these things by hand. And it's possible to do things by hand. I know you can do it. Okay, so I just put it in like I see it. I'm expecting to get 11. If I don't get 11, that means that I have made a mistake somewhere and I need to go find it. But I did get 11, so this worked. And then you also need to check in equation 2. Just because it worked in equation 1 doesn't mean it'll work in equation 2. If you make only one arithmetic mistake in all this arithmetic that we did, we were counting our arithmetic last semester because people were telling me that I'll put the rice on, baby. I'm making a video. It's okay, no problems. Okay, sounds good. Bye-bye. Sorry, we're coordinating our dinner. But I ask people, well, how good does your arithmetic have to be in order to do math? And I mean, is it good enough to be accurate 9 out of 10 times? And I just want to show you that if you're only accurate on your arithmetic 9 out of 10 times, that means you'll have every single one of these problems wrong. Because look at our arithmetic that we did. First, we multiplied 1, 2, 3 times, and then 4, 5, 6 times, right? Oh, no, we just multiplied 3 times because we only had to do the top when we did this one. 1, 2, 3. Then we made an add 4, 5, another add 6, right? So if you mess up there, and then a divide 7. So just to find x, we made 7 arithmetic decisions, right? And I didn't even count coming up with the least common multiple, so you can give me that's at least one arithmetic decision, so 8, right? And then here 9, because we multiplied 10, 11, 12, 13, 14, adding them 15, 16, 17, dividing 18, right? And so at least 18 arithmetics, maybe even more, depending on how you count them, in just getting to where we've got right now. And if you're 9 out of 10 accurate, then that means, we did way more than 10 arithmetics, and that means you got one of them wrong, right? And so people tell me, well, how about 99 out of 100? Would that be accurate enough on my arithmetic? And the answer is, well, I mean, it's not going to take us even doing, 3 or 4 of these before we have that kind of arithmetic up there, right? I mean, it's a lot of arithmetic. And so you really have to be accurate on your arithmetic. And since we're not, you have to check. And so that's why we're checking in the original. Because no one is 100% accurate, and that's what it would take, and nobody is that. I wish I was closer to that. It would be good. And so this is equation 2, right? 7x plus 8y, but I'm putting in what we said, is 7. And so now I'm going to put that in my calculator. And I'm going to do a little editing since it was in the standard form, because I've already worked hard to put 37 over 13 in there. So I'm just going to edit back there. So you saw I just started pushing that button. And I really want the 5 right there. I want the 5 to be a 7. So I'm going to delete the 5 and I'm going to put a 7. And then I'm going to come over here. And I want the 2, and you have to be after it, but you get used to it. And then the delete kind of backs up on it, 8. Now I'm hoping that equals 7. If that doesn't equal 7, then I have a mistake somewhere. Oh, hot dog, it does. And so that's what you want to do. So you don't really have to input it all again. You just have to be able to edit a little bit. So that's what I like about this calculator, is it's really nice that way. Okay, this is problem 34 in your book. And so again, we're going to try the elimination method. And step 1 is done. This is in standard form. And this is in standard form. And if we wanted to eliminate, what variable would you eliminate? And no matter what you say, I'm going to say flip a coin. Whatever it is, I wish I had a coin, I'd flip it. I'd probably run and spin my coin if I had it. And so if you eliminate, I've been eliminating y both times, so I'm going to eliminate x, just to mix it up, right? And so I'm thinking about the coefficients of x, and I want to find the least common multiple. And you could do count bys for 8, right? And the other was, this was for 4, and this is for 8, right? 16, but they have 8 in common. If you wanted to count by 4s and count by 8s, they have 8 in common. So all I have to do is make this. Now remember, you want them to be opposite. So the least common multiple is 8. A lot of times students will ask me, they'll say somewhere in their life they were taught just to multiply them together and get 32 and use that. And it's not the least common multiple, but it's a common multiple and it would work. Your numbers will always be bigger and you'll always have to reduce if there's, or whatever, but it'll work. And so, but anyway, so I like to find the least common multiple. This is my thought on finding it. I want to make one of them be positive 8x, and I want the other one to be negative 8x, so that when I add them together, I get 0. That was how I will eliminate the x, right? And I notice that this one is already behaving the positive, right? So I want to make the other one be the negative. So what would I multiply 4 by? I'm going to have to multiply so that I get negative 8. It's already got the x, right? So I'm really thinking 4 times what is negative 8? If you wanted to do divide, you could. Negative 8 divided by 4 is negative 2, right? So I want to multiply by negative 2. Now it's not good enough to multiply that by negative 2 and not change these. You have to multiply all of them. And sometimes people make a mistake because there's not a number there in front of the y. So I'm going to put the number in. It's 1. So when I multiply by negative 2 here, I get negative 8x. When I multiply by negative 2 here, a negative times a negative is a positive. 1 times 2 is 2y. And when I multiply by negative 2, I get negative 4. And up here, remember, I did nothing. Do nothing. That's a song. Do you guys want me to play it for you? It's a song by Louis Armstrong. And so look it up. It's a pretty good song. I might be playing that tomorrow. Probably I will. You never know with me. And so you do nothing, right? And so this is, because it was already perfect, 8x minus 2y equals 2. And so when I add these together, I get 0 as planned, but I get 0 there, and I didn't really plan that. And there's my first hint that something is going wrong, because I expected to get a variable on this side, but I'm getting a number. And then over there, I get negative 2. And since 0 is not equal to negative 2, this tells me that there is no solution. You can write the word no solution, or you can write the symbol for no solution. And this is the symbol for no solution. Your choice. Now, I like to know that I haven't made a mistake. And so, and there's lots of different ways of making sure that you didn't make a mistake. So on these where you found a solution, you plug it in. But on this one, I don't have a solution that I can plug in. So how can I make sure? So don't make your zeros like this, friends, because if you make your 0 like this, I will think it is the math symbol, no solution, right? So sometimes people tell me that they were taught to make their zeros like this. And I say to them, don't do that. And in chemistry, you're going to learn that this means something different as well. And so anyway, so how will I check my answer? I can't plug in no solution. How would that work? And there's more than one way of checking your answer. One way of checking your answer would be to graph that and graph that. And then what would you expect to find on your graph if you did that? Yeah, parallel lines. 2 independent, separate lines that are parallel, right? That they're going along parallel with one another. They might be like this parallel, they might be like this parallel, but they don't cross one another, right? That's one way of going. The other way of going is to solve for y, both equations. And so your choices are to graph them both, or to check them and make sure they're parallel lines, or to solve them both for y. So that's what I'm going to do as my check. And actually checking them is almost as much work as, so taking away 8x, as solving it was taking away 8x. And I remember I could write that before it or after it. So I get minus 2y equals, and usually in algebra you write it before. So I usually kind of say, hey, that's going to go before. Minus 2x plus 2. And then I'm going to divide by negative 2. Now this was equation 1. EQ1, equation 1. Y equals, a negative divided by a negative is a positive 4x. A positive divided by a negative is a negative 1. This is still equation 1. It's just remodeled. It's looking different, but it still has exactly the same solution set. And I know right here that the slope is 4. And remember, parallel lines, that means they have the same slope. So now we're going to go look at equation 2 and see what its slope is like. So we'll go look at it. And how you can find its slope is just like we learned in chapter 2, is to solve for y. So I'm going to take away 4x, and I'm going to take away 4x. I'm going to put it in the front. Negative 4x, remember you have to have a sign, plus 2. And I'm going to divide by negative 1 here, right? Divide by negative 1, divide by negative 1, divide by negative 1. So I get y equals, a negative over negative is a positive 4x minus 2. Okay, so they have to have the same slope. So the slope here, I will say slope of line 1 of equation 1 is 4. Slope of line 2, is equation 2, is also 4. And so for it to have no solution, they both have to have the same slope, but not be exactly the same line. And you see that they have different y-intercepts. And so this is right? And so it was actually almost more work to check it. You could also checked it by using graphing and seeing and noticing that they're parallel with one another. Okay, and so that's kind of the story on those ones, and we did a lovely job on those. I realized that I didn't have one that had an example on having infinitely many solutions and the fancy notation for infinitely many solutions, because I had in my face-to-face, I had them do that. Remember, I told you guys that every single day how we did it was a little bit different. So I am going to add a problem on here right now that we're going to do. And I apologize about that. Oh, I guess I could probably, well, you guys probably already printed the notes. So I'll add that on there. So I have to be silent for a second while I find it. That one was 34. I'm going to have to make my own. Did you ever have to make your own? Because I'm not seeing one that was just like I wanted. I know that it's there, but doing my math in my head while you wait is not something that is working out that well for me. So I'm going to make my own on this piece of paper right here so that we can talk about it. And then I'm going to make some dinner for my family. So this is example. Okay. So let's pretend like we were trying to solve this. And so if we wanted to solve this, we could eliminate x or we could eliminate y, and it's flip a coin, whichever one that you want to do. I'm going to eliminate y just so that I can be a sing-song and go back and forth, right? And because this has a 1, and that's the reason I wanted to eliminate y, so that I can talk about when I find the least common multiple, right? When one of them's a 1, you can do no better than just multiplying them together, and that will give us 2, right? For the least common multiple. You could do your count bys if you wanted as well. So we have 2, right? And we have 1. And so when we count by, we would get 2 and 4 and 6, right? And when we count by ones, we get 1 and 2. Oh, they have 2 in common, right? So definitely you could do it the count by method. So I want one of them to be positive 2y, and I want one of them to be negative 2y, so that they are opposites of one another. So I already got the one being negative 2y, right? So I don't have to worry about making it. I got it. I need to get positive 2y. So what would I multiply this by to turn it into a positive? Yeah, I got to multiply by a negative, right? And in fact, I got to have, because I got to turn it into a 2. So 1 times what would make 2? Yeah, 2. So I'm going to do that to every piece here, right? Times negative 2, times negative 2, times negative 2. And so this is going to give me negative 8y plus 2y equals negative 4. And here we were going to do nothing, like Louis Armstrong would do. And so you can check it out. His song, Do Nothing. Do Nothing Until You Hear From Me is the name of the song, I believe. And I hope that you do check it out. It's a blast from the past for certain. Maybe even too old for your grandparents. But really good song. So I notice now that these drop out and make 0, right? 0 plus 0 is 0. And different than what we had before is that this is making 0. And so 0 is equal to 0. And so this is telling me that there is infinitely many solutions. This is what this stands for. Infinitely many solutions. And there is fancy notation that you must use for that your book uses. And it's this. This is saying the set. Because there is more than one solution, I have to write it in set notation. There are infinitely many solutions. And then this says of ordered pairs that look like this, x comma y. And then this says such that. That's what that says, such that. And so this is saying the set of ordered pairs, x comma y, such that, and then just pick any one of these because they're exactly the same. So typically a person picks the top one that was given, 2y equals 4. And then you end. So this is our condition. These are the same line. If I was to graph them, they would be the same line. So this is your answer for the back of the book. That's what they'll say in the back of the book. I have to have a way of checking my answer, right? I always check my work. So check. And so what you're checking is that they're the same line. And so one way that you could check that they're the same line is to graph this line and to graph this line and then verify that, yeah, they're the same line. Another way of checking that they're the same line is to reorder them and solve for y, if you like, or that was equation 1, and here's equation 2, equation 1, or equation 2. That means that I ought to be able to do something to one of these and make it look just like the other. And you probably can see that, well, all you have to do is multiply this equation by 2, right? And it'll look just like that one. Times 2, 8x. Times 2, minus 2y. times 2 equals 4. So you see that they're exactly the same equation. They're just a multiple different from one another. And so that when I graph this, and when I graph this, they're exactly the same. They don't have any different solutions. And so that's a way of checking, is just to say to yourself, what would I have to do to both of them or one of them to make them look exactly alike? You could also solve both of them for y and see that they're the same line and slope-intercept form if you wanted. That would be great. And so are you guys going to go listen to Louis Armstrong? I hope you are. And so so check that out, and I'll see you guys in the next video.